Welcome to this lesson on the equation of a circle. There are two main things I want to point out to you here. You can have a very basic circle which has a center at the origin of the x and y plot. That would be this smaller circle here that I drew. This is the equation of a circle when the center is at the origin. And origin, once again, is 0, 0. It's a point 0, 0. However, you may have already guessed this, but not all circles will have the center at the origin. Circles could be moved left or right, could be here or there or anywhere really on this x and y plot. When that is the case, then we would have to account for their movement, the left and right movement and up or down movement, if any, using this formula. So you notice there's now a minus h. We had an x squared, but now there's a minus h on the x squared. We simply had a y squared, but now there's a minus k on it. So what that means is the graph has been moved somewhere along the x-axis, either left or right, and the graph has been moved somewhere along the y-axis, either up or down. So whenever that's the case, you can find the center of that circle by simply taking h and k. Those are these values, but remember, you have to change the sign of them. So if this were something like x minus 4 to the second power and y plus 3 to the second power equals some number like 9, the center of that would have to be 4, negative 3, because you have to switch the h and the k. Further, you notice that on the right side of the circle equations, we have r squared, radius squared. So going back to that same example that we were looking at, r squared was 9. Meaning the radius would be, if r squared is 9, to find the radius, we would just need a square root. So r is by itself, the radius would have to be 3. And that's the general idea behind the equations of circles. So let's just take a moment to write out the equations of these two circles that are drawn on this screen. So here's the first one. Notice that its center is at the origin. So we're looking at the more basic formula. For this one right here, it would be x squared plus y squared equals, we just need to figure out the radius of it. Radius is from the center to a point on the circle. 2 places. So the radius is 2, so we need 2 times 2 because 2 squared. 4. That's the equation of that circle. Let's say we wanted to find out the formula for this blue circle. Notice that it's now been moved. Its center is no longer at the origin. So we have to find out where the center of this is. And it looks like it's about right there, where x is negative 6. X is negative 6, and y is positive 6. So to write out that equation, we would say x plus 6. Remember, you have to switch the signs. Squared plus y minus 6. Because we have to switch the signs. Now, what's the radius of that circle? Let's see. 1, 2, 3. The radius of it is 3, but the formula calls for radius squared, so we would have to say 3 times 3, which is 9. Understand that we don't always have circles presented to us in the standard form. They are sometimes given to us in general form, and we would have to do something to convert them from general form to standard form. And that's the next lesson. So see you there. Welcome to this lesson on how to convert the equation of a circle from general form to the standard form. Please note that these types of questions are going to require you to be well versed, or rather pretty proficient, with completing the square method. We learned about completing the square back when we were looking at quadratic equations in this course. So if you're a little fuzzy on how to convert from standard form to vertex form, I highly suggest that you go back to the quadratic equations lessons and find how to convert quadratic equations from standard form to vertex form. Notice that we have 2 examples here, this one and that one. They're very similar in how we will approach them, but if you remember, completing the square can only be conducted when the leading coefficients are 1. So I wanted to contrast these two by giving you something slightly more challenging on the second attempt. So we'll try that together. Let's go ahead and do the first example here. Remember, when you're completing the square, you have to write the equation and then leave blanks. But first, these are out of order. We want to bring the like terms closer together. So the x's, let's group those closer together. We would have x squared plus 14x plus, here's where we leave a blank, and then bring in the rest, which is y squared, and minus 2y. So y squared minus 12y. Once again, we leave a blank here. Remember that the constant, when you're completing the square, belongs to the right side. So we have to move it over by subtracting 4 from each side. And of course, those would cancel. So on the right side, we would have negative 4. But remember, if we leave blanks on the left side, we have to have those same blanks on the right side to keep things in balance. So let's go ahead and do that. So it would be plus blank and plus blank. And now, how do we fill in these blanks? If you remember, we were saying the b value divided by 2, and then we're going to square that. Only that we're doing it now for two equations. We do have this first quadratic equation, and there's this second quadratic equation. So for each of those, we have to do b over 2 squared. Well, the b value for the first one is 14, so 14 divided by 2 is 7, and 7 squared is 49, so we put a 49 here, and of course a 49 will go right there. On to the second one. So our b value this time is negative 12. Negative 12 divided by 2 is negative 6. Negative 6 squared is positive 36. So this will be a 36. And of course, that will be a 36 as well. And now let's continue working on this problem. On the right side, we find that we just have constants, so we can combine them. Negative 4 plus 49 is 45. 45 plus 36 is 81. So 81 will be on the right side. On the left side, remember, when you are completing this square, after you do the b over 2 squared, life is so much easier. You don't even have to do any math at all. You just take the first quadratic equation and you set up two parentheses with a squared on them. And of course, you'll do that same thing for the other one, parentheses with a squared on them. And then you will always copy the first sign. So for the first one, we have a plus. So this is going to be a plus. For the other one, we have the first sign is a minus. So that's going to be a minus. And to fill in these blanks over here, we are simply taking the square roots of the first and last terms. So the square root of x squared is x. The square root of the last term there is 49. So the square root of that 49 is 7. On to the other one. Square root of y squared is just y. Square root of the last term, which is 36, is just 6. And now you realize, just by doing what we just did, we have now arrived at the standard form of that circle. If the question was to find the center of that circle, which could very well be, we know how to read that, because the center of the circle is simply taking this value and that value and of course changing their signs. So the center for this circle would be negative 7, 6. And the radius for this circle, remember this is always r squared. The radius of the circle would be the square root of that number, which is 9. And now that we've gotten an idea on how to convert from one form to the next, from general form to standard form, I feel we are ready to try a slightly more advanced example, which means we can do this problem now. I'm going to use a different color for contrast here. I'm going to use blue. So recall, we can only complete the square if and only if the leading coefficients are 1s. We have a problem because they're currently 2s. However, when we were learning how to factor, we found out that the most basic form of factoring, which we should always look for every problem that we are factoring, is using the greatest common factor. Lucky for you and I, these have a greatest common factor. 2 goes into all of them, which means we can factor out a 2, which then is going to leave us with x squared plus y squared minus 10x minus 4y plus 25 equals 0. And the next thing I'd like to do is get rid of this 2. We can do that by dividing each side by 2 as shown, which means these 2's cancel out. In fact, I can just get rid of those. I'm going to erase them. And on the right side, we just have 0 divided by 2 is just 0. So with that said, we can see that our equation is simply going to be this part right here. And now that puts us on par with the first example, whereby we could just complete the square. So let's go ahead and do that. First, we have to group the like terms together, so the x's need to be closer together. We have x squared minus 10x plus, leave a blank space, and bring on the y. So y squared minus 4y plus blank equals, remember the constant belongs to the right side, so we would have to move it there by subtracting 25 from each side. So on the right side, we have negative 25. And now we can move forward by filling in these blanks. Remember, blanks are filled by using the tiny little formula b over 2 squared. Well, the b value here is negative 10. Negative 10 divided by 2 is 5. 5 squared is 25. So if you put a 25 there, you have to put a 25 on the right side as well. Now on to filling in this blank. B value is negative 4. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So if you put a 4 there, we have to put a 4 here also. Once again, working out the right side is easy because these are just straight up numbers. Negative 25 plus 25 is 0. 0 plus 4 is just 4. And of course, on the left side, we now have the 2 quadratic equations, which factor beautifully because we are completing this square. So go ahead and set up the 2 parentheses for each one. Again, always copy the first sign for each one. So the first sign here is a negative, so that's a minus. The sign here is also a negative, so that's a minus. These blanks are filled by taking the square roots of the first and last term. Square root of x squared is x. Square root of 25 is 5. For the next one, square root of y squared is y. Square root of 4 is 2. And there we have the standard form of this general form equation of a circle. Once again, if you were being asked to find the center is found by switching the signs of h and k. This is h, this is k. So the center of this would be 5, 2. Once again, the radius is found by square rooting this number. So the radius would be the square root of 4, which happens to be 2. And that concludes this lesson.